Okay, so in the world of live broadcasting, there are literally no do-overs, right? A single mistake can cost millions of dollars. Today, we're looking at a brand new kind of technology that's designed to stop those mistakes before they even happen. It's called Agentic AI. So let me just start with a big question. Imagine you're running a massive live event, okay? Millions of people are watching. What if you could fix a critical failure before it ever reaches their screens? So fast that your audience has absolutely no idea that something even went wrong? Well, that's the promise of what we're digging into today. Now, to really get why this tech is such a game changer, you first have to understand the world it lives in. So let's step into what you could call the live broadcast minefield. And believe me, that is not an exaggeration. When you're broadcasting live, that's it. There is no second take. A frozen screen, a total loss of audio, a signal dropping right at the end of a championship game, that's not just some glitch. For a network, it's a disaster for their reputation, for their revenue. Every single second is absolutely critical. For decades, the industry has basically relied on this reactive firefighting model. You can see it on the left. An alarm goes off, an engineer has to figure out what's wrong, and then they have to try and fix it. This whole thing takes precious minutes. Now compare that to the new model on the right, which happens in seconds. And in live TV, that difference is, well, it's everything. So what if you could take all those frantic minutes of panic and just compress them into a few seconds of automated surgical precision? This is where a totally new kind of automation comes into play. So let's meet Agentic AI. Okay, so what in the world is Agentic AI? Well, the key word here is agentic, which comes from agency, the power to take action. This isn't an AI that just flashes a warning light on a screen. No way. It's a system that actually observes what's happening, analyzes it, makes a decision, and then, this is the crucial part, executes a fix all by itself. And this really gets to the heart of it. Most AI that we're used to is kind of like an advisor. It just gives you an alert, like you see on the left. But Agentic AI, that's an actor. It doesn't just tell you there's a problem, it goes in and autonomously fixes it, all while staying inside the safe boundaries that the human operators have already set up. So the whole point here is how this completely rewrites the timeline for solving a problem. We're about to see how operations shift from minutes of frantic manual work to just seconds of pure autonomous action. All right, so here's how it works, step by step. First, you've got all this data just pouring in from all the live systems. Second, that data gets collected in something called an observability layer. Think of it as a central nervous system for all the equipment's vital signs. Third, the Agentic AI engine is constantly analyzing all that data, deciding what to do. And fourth, it acts. It executes the fix instantly. The first time a human engineer might even hear about it is when they get a notification that says, hey, problem detected and already solved. And the AI's vision here is, well, it's total. It's not just looking at one little box. It's connected to everything. We're talking playout systems, encoders, media servers, the network, the cloud, the whole shebang. And that complete end-to-end view is so important because a problem that pops up in one place might have its real cause somewhere totally different. The AI can see that whole chain. So what can it actually do? Look, we're not talking about just turning something off and on again. This is sophisticated stuff. It can seamlessly switch to a backup server, reroute a signal around a broken network path, or even build new cloud infrastructure on the fly if it needs to. It's like having a superhumanly fast engineer on duty, 24/7. Okay, so what does this incredible level of autonomy actually mean for a broadcast operation day to day? Let's talk about the real-world impact. The results are pretty staggering. You can see the impact right here in 3 key areas. That first bar shows that the speed of fixing problems just skyrockets. Because of that, the second bar shows that the number of on-air failures just plummets. And of course, that third bar shows that the manual workload for the human teams goes way, way down. So for the business, this is a complete paradigm shift. The operations center goes from being this high-stress, reactive firefighting unit to a proactive, strategic team. They can now focus on optimizing and actually improving the system because the AI is handling the second-to-second stability. Of course, anytime we talk about this kind of powerful automation, there's a huge question. What about the people, right? What does this all mean for the broadcast engineers? Well, their role doesn't disappear, it evolves. They become the pilot and the AI becomes their co-pilot.
And let's be crystal clear on this, because it's the most important point. The engineers remain firmly in control. This is not about replacing human expertise. It's about making it more powerful.
You see, the AI only operates within a framework that is designed entirely by humans. The engineers are the architects. They're the ones who define the policies. They set the thresholds for when the AI should act. They build a safety guardrails, and they decide the escalation paths for when a problem really does need a human touch. Their job shifts from being a manual fixer to a strategic system designer. And this quote from the source material just sums up this new partnership perfectly. Agentic AI is not replacing broadcast engineers. It is becoming a virtual operations assistant that keeps systems stable in real time. It's just an incredibly powerful tool in the hands of an expert. And that brings us to one final, much bigger thought. We've seen how this can completely transform live broadcasting, one of the most demanding, high-stakes environments on the planet. So the question I'll leave you with is this. What happens when every critical industry, from our power grids to air traffic control, gets an autonomous co-pilot that never, ever blinks?